Today we are going to discuss per unit calculation for a power system. Here there is a single line diagram for a power system is shown in figure. The single line diagram comprising of a generator, motor, two transformers and transmission line. So we are going to calculate per unit value for the power system. Per unit value is nothing but an actual value to the base value. Here what we are going to do is, already a per unit value is given for all the components present in the power system, but we are going to take a new base value. For that we are going to calculate the per unit for all the components present in the power system. Here a single line diagram is shown in the figure. You can see that there is a generator, transformer 1, it is a transmission line, transformer 2 and motor. So all the values which are given in the nameplate are called as the old base values. For example, you can see that there is a 30 MVA, 10 kV and X is equal to 8%. So these values are given in the nameplate detail. So these are all the old base values. Similarly, you can see that all the components are presented by their corresponding specifications. So these specifications given in the nameplate detail, which are all called old base values. So what is our aim is to calculate the new per unit value for all the components present in the power system with the help of the new base values. So as per this problem is concerned, we are going to take generator value as a new base values. So based on that new base values, we are going to calculate the per unit value for all the components present in the power system. For example, you can come to the generator side. So what is given here is 30 MVA, 10 kV and X is equal to 8%. So these are all considered as old base values and old values. Now with the help of the new base values, we are going to calculate the per unit value. So the formula for the new per unit value is given here. You can see that X per unit new is equal to the old base value and the old base values and new base values squared multiplied by MVAB new by MVAB old. So with the help of this formula, we are going to calculate new per unit value for the reactants present in the components present in the power system. The example is given here. For generator, how we are going to calculate the new per unit value, and similarly we are going to calculate all the new per unit value for the components present in the power system. So we will take one by one. So first we will take the generator. So then generator old base values are given here, and what is the new base value? I already told you that. So we can take new base value as a generator side. So the generator side 30 MVA and 10 kV. These are all the new base values. So MVA new is equal to 30 MVA and kV new is equal to 10 kV. So this is going to act as a new base value for all the components present in the power system. And one thing we have to keep in our mind, that MVAB new 30 MVA, this is going to act as a common value for all the components present in the power system. At the same time, based on the transformer position, this kVB value going to change. That is, the new kVB value going to change due to the presence of the transformer. So one by one we will going to see how the new per unit value for all the components are going to calculate. First one, generator. So what are the old values? Old values, 30 MVA is old value and 10 kV is old value. X is equal to 8%. These are all the old values. Now with the help of the new base values like 30 MVA and 10 kV, we are going to calculate what is the new per unit value for a reactance of the generator. So then now we can substitute the values in the formula and we can get the new per unit value for the reactance of the generator. Here you can see that X per unit new generator is equal to, what is the old base value? It is a 8%. This is given in the problem. So it is become a 0.08 and kV old is 10, which is the nameplate detail, and kV new, which is 10 kV. As per this formula is concerned, 10 kV is acting as a kV new. Next 30, this is the MVAB new. Other day I told you that this 30 MVA is going to act as a common base value for all the components present in the power system. So again 30 by 30 and finally you will get 0.08 per unit as a new per unit value for the generator. Next we come to the transformer section. So what is the values available in the transformer 1? The transformer is rated as 11 or 110 kV. It is a step up transformer and the rating of the transformer is 25 MV and the reactance value is 10%. So now this 10% is going to modify as a new per unit value based on the new base values. So new base values are 30 MVA and 10 kV. Now how the per unit value for the transformer 1 is going to change. Now we can come to the formula. So X per unit new. This is the transformer 1's new per unit value for the reactance is equal to, what is the old value which is presented in the nameplate 10%. So 0.01. This is the old per unit value, and what is the kVp volt which is present in the primary side of the transformer? The kVp value is 11. So that is going to be presented here 11 by 10. So 10 is nothing but the kVp new value multiplied by what is the MVA new? 30 MVA. It is a new MVA. So 30, and what is the rating of the transformer? This is 25 MVA. So which is presented here. So finally the new per unit value for the transformer T1 is equal to 0.145 per unit. Now we come to the transmission line section. So here one point we have to see. It is J100 ohm. So the actual value is present here. Unlike this 8% and 10%, the transmission line is represented by its actual value. The formula is slightly different when comparing the generator and the transformer. Now we are going to calculate what is the per unit value for the transmission section. So for that, the formula for the per unit value is per unit reactance of the transmission line is equal to actual value by base value. So actual value is equal to J100, which is presented in the problem itself, J100, and the base value we have the formula. So the base value formula is equal to what is that? kVp squared divided by MVAB. So these are the new base values for the kVp and MVAB. So already we told that MVAB, it is a constant throughout the system. So this 30 MVA is going to act as a MVAB new. But this kVp is going to change because of the presence of the transformer. Since the transformer is transforming the power from one side to another side, so that 10 kV is going to transform into another side. So the new base kV for this section of the secondary side of the transformer can be calculated like this. So when we are applying the 10 kV on the primary side, what will be the secondary side of the kVp? This is going to be 100 kV. So 10 into 110 by 11. It will give the 100 kV. This 100 kV is going to act as this side. This kVp is not only for this transmission line. This 100 kV can be applied for the primary side of this transformer T2 also. So now the per unit value, new per unit value for this transmission line can be calculated like this. With the help of this formula, we can calculate actual value by base value. So already I told you that this is actual value J100 by XB, and the formula for XB is kVp squared by MVAB, and kVp just now we have calculated this 100 kV is going to act as a new kVp. So 100 squared divided by 30, and finally you will get 333.33 ohm. This is the base value. Now the per unit value of the transmission line is equal to actual value is 100 and base value is 333.33. So finally the result is 0.30 per unit. Now we come to the primary side of the transformer T2. So now again you can see that the old base values are given in the nameplate to 20 MVA. So this is going to be a step down transformer button bar 11 kV, and the reactance value is 20%, and this can be written as a per unit as 0.20. So this is the old per unit value. Now we are going to see what is the new per unit value. Again we come to this formula for the transformer T2. So what is the new per unit value of the reactance of the transformer T2 is equal to, so the old value multiplied by kVp volt by kVp new square and MVAB new by MVAB volt. So the kVp volt is what is represented in the transformer side 110 kV. 110 it is the kVp volt. What is the new kVp? This is just now we have calculated 100 kV. This is presented here, and 30 it is a common value. MVAB new is a 30 MVA, and the rating of the transformer T2 is equal to 20 MVA. This is going to act as a MVAB volt. So the finally the result is what is the per unit value of transformer T2? New per unit value of the transformer T2 is equal to 0.363. Now we come to the motor side. So before we come to the motor side, we have to calculate one more time what is the new kVp for this section. Since the transformer is presented here, what is the primary side voltage? It is 100. 100 kV is acting as a base value for the primary side of the transformer. Now we have to calculate what is the secondary side voltage. The kVp new is equal to, so based on this 100 is when 100 kV is applied to the primary side, what will be we expected in the secondary side of the kVp? It is calculated like this, and you will get 10 kV as a new base kV for this section. So this is going to apply for the motor. Now we calculate what is the per unit value for this motor. So the volt base values are 8 MVA, X is equal to 10%, and the volt kVp value is equal to 10. So from that we can calculate what is the new per unit value for the motor. So finally the answer is the motor new per unit value reactance is equal to the volt value is equal to 0.1, and multiplied by kVp volt by kVp new. What is kVp volt? Which is present in the nameplate detail, 10 kV, and what is the kVp new? Which is just now we have calculated. What is this 10 kV is going to as a new base kV, and multiplied by MKV new is equal to, which is common for all the components, 30 MVA, and the rating of the motor, it is a old MVA value, it is 8. So 0.375 per unit. So likewise we can calculate the new per unit value for all the components present in the power system with the help of a new base value. Now I think you will understand what is the per unit value, how it is going to calculate it with the help of new base value. Thank you.